The Kirchhoff Voltage Law, abbreviated with KVL, is one of the most important laws that you need to know in order to solve electronic circuit. As indicated on the side here, this is the definition of the Kirchhoff Voltage Law, and it basically says that the sum of all the voltage in a loop must be equal to 0. What is a loop? A loop is any path traced from one point in the circuit around other points in the circuit and then back to the initial point. So very simple definition. How do you actually implement that practically speaking? So I'm just going to show you very simply with an example on the right. So you see here a simple circuit. It's actually the most complicated circuit you have seen so far. We have 3 components. We have a battery. We have 2 resistors, R1, R2. Now we don't know exactly what is the value of the resistor, and that is not really important. We know that the voltage of the battery is equal to 5 volt, and we know that the voltage across one resistor is equal to 3 volts. Now, what is the voltage across the resistor R2? Probably very simple to understand what is the voltage at that point, but some circuits might be more complicated than others, and so it is important to understand what is sort of a formal procedure to follow to make sure your result is always correct. It's pretty simple to implement. So what you do, let me take my green pen, is that you identify the loop. Here we only have one loop, so there's no doubt. You pick a random direction for the voltages. That is already done. And when I see a random direction, I mean apply a random orientation for the arrow of the voltage. Like in this case, we know, okay, the 5 volt is in this direction, so the potential is higher here than here. We know that 3 volt is in this direction. V2, we don't know yet what is the direction of the voltage. It could actually be directed the other way around. It doesn't matter. I decide that the voltage most likely is directed in this direction, so there is a higher potential here than here. So that is totally random. Then you assign a direction of the loop. So you have this loop, you just write a circle here, and you decide, let's use this direction as a convention. Any direction is fine. It can be clockwise or counterclockwise. And now all you're going to do is that you're going to sum all these voltages together, and the one that goes with the same direction of the circle are going to be positive. The one that goes with the direction opposite of the circle, they're going to be negative, and the total sum has to be equal to 0. So in this case, 5, it's going in the same direction of the circle, so I'm just going to write plus 5. Now when I get here, 3 is the opposite of the circle, so minus 3 volts. V2, I don't know what is the value, but I can clearly see that it's going in the opposite direction of this arbitrary orientation. So minus V2, and now we completed the circle, so equals 0. Now this equation can be solved. I will give very easily the solution, which is V2 is equal to 2 volts. Easy, right?